Hello everybody and welcome to this week's edition of ayedo Masters with Kubernetes. Today we are installing Otomi, a self-hosted platform as a service for Kubernetes, and we are going to install it, and you guessed it, Kubernetes. Otomi is a very cool tool. It's been built in the Netherlands, it's fully open source, it's built by the great guys from Red Cubes. And it comes with a whole set of configuration and ideal setup and applications that are fully integrated with each other to give your team or teams a safe space to run, deploy, and manage Kubernetes applications. Not only your own applications, as you can see, you're free to install and use industry standard cloud native applications for application performance monitoring, image storage, serverless, CI, CD, and authentication. And Otomi makes it very easy to onboard multiple teams, maybe from a big corporation, and have them isolated with isolated namespaces where they can do their magic without interfering with each other. But we will go into the specifics of Otomi during the installation. It will take between 5 and 10 minutes. And I will also explain how these apps work together, and I will explain a little bit of the details that the installation process and the update process of Otomi is depending on. We're using two tools for this. For one, we're using Polycrate, the DevOps framework, which is something we built in-house. I won't go too deep into that because we have another section of videos and blogs explaining what Polycrate does. And we're using one of our ayedo fleet managed Kubernetes clusters. They are running on Hetzner Cloud in Germany and the EU. So it's a great European alternative to the big hyperscalers, and it's also a very price sensitive alternative to the hyperscalers. So let's jump into it. What you see on the left is a so-called Polycrate workspace. I've prepared that already. It's called Otomi Fleet, and we have prepared a so-called block for Otomi. Polycrate is built of blocks, and the block you can imagine a block as a bundled piece of code with a certain set of actions you can execute on that code. We use this to install or uninstall or upgrade things. It's hooked up with Kubernetes. As you can see, I have a plugin called a block called Fleet, and that has an artifact kubeconfig. I downloaded the kubeconfig from our Fleet services and put it here into the workspace. And Polycrate makes sure that whatever is executed here, whatever action we run, works against exactly this Kubernetes cluster that we define here in the kubeconfig section. For Otomi itself, we at this point do not need any more than the admin password. Of course, Otomi has way more things to configure, but for this tutorial today, we will only do the base installation of Otomi because this works with pretty much any Kubernetes cluster, even Minikube or whatever you have locally. So we will start with inspecting our workspace, which at first will result in an error because we started from scratch and we defined the dependency here to download our vendorized Otomi block to instantiate a virtual block from this one. This is simply called Otomi, makes things shorter. And you can imagine this like a class or a library. And you can instantiate multiple of those virtual blocks from that library block. That makes it easy to use Polycrate to work with multiple environments like development, QA, and production inside the same workspace. And now that we have inspected once, Polycrate managed to download our library dependency, and now when we inspect, we can see the compiled workspace. There is a lot of stuff in it, mainly configuration for Otomi. As mentioned today, we're only looking at the base install. There will be follow-up series of that blog and video where you can learn how to upgrade Otomi, how you can enable and disable certain features, how you onboard your teams and actually work with it. But today, we just want to get it up and running on Kubernetes quickly. To do this, we call Polycrate run Otomi install. This will mainly do what's documented in the official documentation. So it adds the Helm repository and then we'll go start a Helm installation, which we execute in template with Ansible, because hey, it's Ansible and everyone loves Ansible. More YAML for the word. If we did everything right, yep, Otomi is already installed, and actually it's not. So what's happening, and I'm gonna explain this now, is Otomi installs a job into your cluster, and this job starts a pod, and that pod contains all the runtime that's needed to install the whole Otomi product, the whole Otomi, I don't know, ecosystem landscape. It's quite a lot. So the Helm release should be somewhere here. Okay, it's deployed. The job should be up and running by now. Why isn't this changing? Okay, that's a little bit frustrating, but we're all used to slow Kubernetes APIs, I guess. So here we are. Here's our job. And what it's doing, what it does is, it started an Otomi pod, of course, that's what jobs do. And this pod, as mentioned, contains the whole runtime. So a whole lot of bash scripts and TypeScripts and the Otomi CLI and whatever. At the Helm installation process, Otomi, or the Helm chart, installed a secret for us, Otomi values, which pretty much contains what we have configured in our templated values that we do with Ansible, and persists this in the cluster. And here's where the magic actually starts, because Otomi is special in many ways. It's not only install, set and forget. Otomi installs a whole suite of very interesting tools. They are all open source. And starting with Gitty and Keycloak, they are very important. So Keycloak is used throughout Otomi to authenticate everything. So you get a free IDP, and whatever you try to use and wherever you need to log in inside Otomi, it will be running through Keycloak, and you're authenticating with the users you're creating there. For every one of you familiar with Keycloak, you know that means you can also hook up another identity provider with Keycloak, let's say Azure AD, and this is a supported setup that we try to implement next time, and log in with your existing users into that Keycloak, and with them authenticating to the rest of the system and the rest of the Otomi ecosystem in your cluster. So it installs Keycloak. It also installs Nginx, because it's trying to find out your cluster IP. That's what I mentioned with base install. So in the base installation, where we do not set a specific host name, Otomi makes a little bit of magic with nip.io. If you don't know that, it's a magical DNS service that you can where you can use subdomains.nip.io, and the subdomain is an IP address. And nip.io will simply return that IP address, which makes these, those kind of things very interesting, where you can simply start something on a server or on a cluster, in our case, with a load balancer in front of it, and then you get an IP address, and you can use that IP address.nip.io to point a DNS record to your cluster, which means you can get valid SSL certificates, TLS certificates. And you can even do this with Cert Manager. And let's encrypt. So we will see when Nginx lands. It's not there yet. Okay, that's pretty sad. I believe there's again something I did wrong. But we can take the logs. Okay. It advanced already to Istio. Something seemed to change from the last time I did this, because actually it should install Nginx. Nginx creates a load balancer, or maybe it's already gone, that's possible too. Nginx creates a load balancer, gets an IP address, and Otomi picks up that IP address to use it as the DNS name prefix, the subdomain for nip.io. We will see that at the end of the installation process, where we use this to log into Otomi. What you can also see here, we got a Keycloak already. It's bootstrapped and integrated with all of the applications inside Otomi. And the second thing that will be installed will be Gitty. Otomi, and that's where the real magic starts, takes care of your day two operations in a very specific way. So once you've installed it and once Gitty is running and everything's running, the values for the whole system will be templated and written to a dedicated repository inside Gitty. It's called Otomi Values. It's an admin level repository. And this repository will be hooked up with Drone. And whenever a change in that repository happens, which is anytime we change something in the Helm chart or in the UI, then a drone pipeline will run, like a continuous deployment pipeline will run, and rerun the whole installation process based upon those new values. That also means once Otomi is installed, you can start configuring it from inside Otomi's Gitty instance, change values, and Drone will make sure that everything's working. Behind the scenes, this is a very complex process. And I'll be honest, it took me a while to get the configuration right and find everything out, where to put stuff, where to change stuff. But once that is running, it's very, very smooth. And you have kind of a self-serving, self-sufficient platform that you do not necessarily need to change from the outside. So you're changing Otomi from inside Otomi and it's still fully GitOps. So you can simply clone the repository, import it somewhere else and restart your cluster. So back to the board. We've a little bit advanced, so Keycloak is already running. We see an OAuth proxy. This one's used to connect all the applications to Keycloak and make sure we can log in the right way. And we should soon see, Cert Manager is already there. And here's a pitfall with the default installation. In the default installation, as you can see here from the job output, Otomi creates a custom CA for us, feeds that to Cert Manager, and whatever ingress or other service we provide through Otomi, it will be fed this custom CA. That also means once you use the base installation in the browser, you will get a whole lot of errors from your Chrome browser, which thinks, self-signed certificates aren't safe. They are, be assured. And in one of the next series, I believe even the next series of that blog, we will show you how to update from the base installation with the dynamic DNS NIP.io domain to a custom domain you use, hook that up with a cloud provider like Azure or Cloudflare, and have DNS records managed and thus get valid TLS certificates for our domain. So that's fully possible. I just wanted to make the base installation today to show you it's not so scary, it just takes a little bit of time if you do it right, and we try to do it right for you with Polycrate. And then you can simply upgrade this. And at the end of the series, you will even learn how to integrate an external identity provider, and we will show you how to work with Otomi, how to deploy your own applications. But back to the drawing board. Otomi comes with a lot of apps, as you can see, and those aren't even all apps. Once we have it installed, we will see the team around Sander is already in the making of more applications that enable you as a team to not care too much about all those configurations. You do not need to know how to properly configure Prometheus, Loki, and Grafana. It's being done for you. That being said, you will have the option to simply drag and drop install applications that you need on a team basis. So you can have those installations namespaced, one for each team. Or you can have some of them, or you must have some of them as core applications running for all teams. I've not figured out which ones are for teams and which ones are core. We will go through that in the next blog post, where you can see me struggling with setting everything up and getting everything running with a multitude of teams. But what I learned is there's a whole lot of multi-tenancy here that you won't get from any other provider. So Otomi is inherently multi-tenancy based. It's meant to support multiple teams that do not interfere with each other. Like maybe you have your application split into a development and a production environment that's being served by different teams. Maybe you have different applications, different microservices that need to run with each other but still be maintained by different teams, and you do not want them to mess around with each other team's code. And Otomi makes that fully possible while still being able to track common metrics over your whole infrastructure, use a common image storage and Git storage, so you have everything on board. Basically, you only need one Kubernetes cluster and you're ready to develop cloud-native services and cloud-native software running in Kubernetes. With Bitnami Kube Apps, I guess you know that one, you can easily install additional software into your namespaces like like databases or what have you, you know. As you can see, there's also Argo CD, which makes it easy to deploy your applications. And again, this is all fully integrated. So once you want to log into one of those apps, like Grafana or Argo CD, you will go through Keycloak, and that might go through another identity provider that you configured. So let's see where we are. Still not fully done with the installation, but as mentioned, there are many movable pieces. And the last times I did this in the cluster of that size, we have 3 worker nodes. They each have 8 gigabytes of RAM. It took around 10 minutes for everything, to fully assemble, so to say. And now we simply wait until this is done. I can try to show you what we actually did here. So when building the Polycrate blog, we simply read along the Otomi documentation, which is actually very good. So I only had to ask the team like 5 times for errors, but they are very responsive and they are very helpful. They want to advance. They want to make this better for you. And we figured out a few things that could be improved on the installation process and how Cert Manager works and stuff like that. And they were super open to discuss, and some of these things have already been implemented like a day later. So big props to Red Cubes and Sander and his team to for making all this possible and giving me the chance to make this a very good experience for our readers and for all of you who are watching the video. So as you can see, we already have a few options in the documentation telling you something about Azure AD as an IDP. As mentioned, we will do this next time. We have a whole lot of enterprise features. There's policies, network policies. There's, as mentioned, the multi-tenancy of completely isolated namespaces. You can work with external key vaults. You can work with the internal key vault. Otomi manages services and ingresses for you, manages the domains for you. So basically, you as a developer simply push code to Gitty. Maybe you write a pipeline for Drone that builds something, and then you hook this up with Argo CD, and magic just happens. It's really amazing. And I've not seen a platform, a self-hostable platform built by European people with that depth. Most of the platforms are software as a service only. They're coming from outside of the EU, and for me as a citizen of the EU and as a German citizen, even if I don't like it very much, it becomes more and more of a thing to look out for self-hostable things. We're working with many enterprise customers from Germany, and it's often simply not an option to go to software as a service vendors and use what they offer. Not only because they're most of the time not from the EU, but also because internal compliance policy prevents this. And Otomi is perfectly capable to run on-premise on your, let's say, legacy infrastructure, given that you can provide a Kubernetes on top of that with a static IP or load balancer that Otomi can use. So what we did is, as mentioned, we just installed it from the chart, and we're doing what they are suggesting. We're just watching job logs, and peak one, whoop, and here we go. Now, it finished like 20 minutes in, which is fine. I talked a lot. I believe the installation itself took 10 minutes, and for the amount of pieces they need to move to make that work, it's actually very impressive to get it done in that short amount of time. So we're copying this URI here. As mentioned, it's otomi.myipaddress.nib.io, and then we simply open that. As mentioned, there will be errors because it's a self-signed CA. I could download and import it, but unfortunately, I will only be able to do this in a user-friendly way once I have logged in. And to log in, I need to go to the Otomi dashboard and through the OAuth proxy and then through Keycloak, which means I have to confirm that this is secure 3 times. Then I'm using Otomi admin and the password we defined in the Workspace config to sign in. That was already Keycloak, and now we're in the Otomi dashboard. And as you can see, we have a cluster that we can select here, which is the cluster that we just built or that we just used, which might highlight that Otomi is able to manage multiple clusters and distribute all its logic over multiple clusters that you can add once one single Otomi instance has been set up. So the first thing we need to do from the documentation is get the output of the log installer job. We did this. Yeah, we won't do this because I'm fine with clicking OK in my browser. That's out of scope because in one of the next blogs and videos we will show how to upgrade the custom CA to a cert manager, managed one with Let's Encrypt and DNS01 validation. So the full enterprise stuff. But we need to do one thing, and this is activating drone. Why would we want to do this? Simple. As mentioned, Otomi is a fully integrated GitOps solution, so you deploy it from a Git repository that's running inside the cluster Otomi is running in. It's just amazing. Never seen such a chicken egg thing in the wild that's actually working. And to get this done, you can see here a list of apps. Those are our enabled core applications. Once I click on drone, it will open. It will probably again show me that it's bad security, which it isn't. And then I simply click here. I will get to Gitty, which already says, oh, I'm so insecure. And here I can again log in with my user and password. Save this for later. And the purpose of this is to hook up Gitty with drone. So we hook up the Gitty Otomi values repository and authorize drone to pull it. You can imagine this like GitHub Actions or Jenkins or whatever, getting access to your Git repository. This here, I don't know why, can simply be left empty. You just click submit and you're good to go. And here you see the Otomi values repository inside drone. I click activate like mentioned in the configuration, and now I have an empty build list. We will show why this is, what this is for in a minute. First, we go back to Gitty, where you see there's a Otomi values repository that has been created by the installer 8 minutes ago. And if we go into it, there's stuff in it. Guess what? In the env directory, there's a whole lot of configuration that maps how the platform should look like, how it should be configured. I will not go too deep into that. Maybe we can or need to touch that at a later point in time. But for now, just think if we change something in the UI, Otomi will write that back into that repository. Let's say here into the apps repository. And then, which one can we take? Let me have a look, because we want to install one in a minute. Something small. Yeah, why not Cube Clarity, which is very cool. So let's say we take Cube Clarity, and here you can see it says apps Cube Clarity enabled false. Pretty, yeah, makes sense because it's not enabled. And how Otomi works is I just pull this down, and then it gives me the option here to deploy changes, which means install that application. And now we can watch the magic happen. I say deploy changes. Once this is becoming green, we can update here and we see it became true. Magic. But the magic isn't over yet. Drone picked this up and now runs a few pipelines. For one, it clones the repository, reads in the values, bootstraps everything. So this is basically, as far as I understand it, rerunning the whole installation process. So it's kind of idempotent, like Ansible used to work, and like we all want our Kubernetes to work. Yeah, right? You're just declaring something, throwing it at the cluster, and boom, here we go. And Otomi is using that to persist your changes in a non-proprietary binary format. So it's not writing stuff into a database where you need to export that and import that and whatever. It does simple GitOps mechanics. So it writes back everything we configure into the Gitty repository running inside Otomi in the same cluster. And then it's running its supply job, which is, wait until it's loaded. Yeah, which is applying it, right? What we could watch in the installer job before, Otomi is doing this for us now. If we're lucky, we should be able to already see a few pods or services from kubeclarity. Yeah, here we go. Okay, you see? So Postgres database, etc. kubeclarity, just for reference, it's a tool that can scan your whole cluster for a software bill of materials and alongside that for vulnerabilities. We will just showcase this shortly and pretty much finalize that for today because Otomi has been successfully installed. We showed how we can install an application on admin level. So this is pretty much available for all of us. And we will show kubeclarity because it's a very cool tool to showcase what the power of Otomi is actually for enterprise organizations. Because kubeclarity can map all the applications, all the images running in your cluster, ingest them and give you a very good visual feedback about what's broken with it, where are the security vulnerabilities, and much more important, what software is being used. So a software bill of material. And once this is running, I assume shouldn't take too long, we should be able to, see that drone is still working, 2 minutes in the making. And it's finished. So for the Git nerds, you can simply check what Otomi did. There's a diff, what happened here. We won't go into depth here, but again, you see the same output like from the installer. That means once we go here, open kubeclarity, do this, we're used to it, we're not secure, and here we are. kubeclarity is running under a fine domain name, HTTPS secured, and accessible from the admin console. And what I do now is simply showcase how kubeclarity works. You start a scan. The scan will launch a few containers here. You can just wait. They will start soon. It will launch a few containers that will scan your whole cluster and all the images in your cluster for certain occurrences. It will map the software used in it. And in my last scan, this stopped somewhere around 92%. But nevertheless, it gave us all the information we wanted. And we won't go on to the end with this because once the software bill of materials has been mapped by kubeclarity, as far as I understand, it takes a little bit more time to also scan all the vulnerabilities and make them available in the UI. As far as I understand, kubeclarity uses Snake for parts of this job and probably other open source or freely available software that you might be also able to upgrade to enterprise level to get more juice. But as mentioned, it's not about kubeclarity, it's more about showing what Otomi can. So we did an install in like 10 to 15 minutes. We have a multi-tenant platform ready at our fingertips that we can use. We showcased that we have enterprise applications in it that your teams can use to not only build and run and deploy and manage Kubernetes apps, you can also audit them on a very high level, which is something pretty much everyone wants in its Kubernetes cluster, but it's not easy to implement for people. And this is like click, boom, go. Okay, it just works. So here we can see a few things already. So there's kubeclarity detected already 3 and 3. I'm a German, I'm so sorry. 33 application resources and like 1,800 packages. And we can go into this and it says a lot of things about the images we're using. Those, for example, are from our base Kubernetes install. It's CoreDNS, we have Cert Manager, we have CSI Attacher. And let's say we want to go into the Cert Manager. This is what we see now. Once all the checks are finished, we will also see vulnerabilities and the CIS benchmarks. But for now, we can see what is used here on the machine, what Go libraries are used. I'm actually not sure how this tool figures all that stuff out, but to be honest, that's fully out of scope, and it's amazing that it's able to do this because it's just enterprise node porn, to be honest. You get a very good insight, and I'm sure it's not 100% perfect insight into the software running in your cluster and your attack exposure. And if you're working in Germany or working for German governments or official agencies, you do have pretty high marks to reach in terms of security and certification. We have the BSI. They regularly publish their understanding of what is a secure Kubernetes cluster or what is secure container image, and this tool here helps to get all of that easily done because it highlights like most of the vulnerabilities in most of the software packages used. Yeah, so let's check the runtime check. As mentioned, it's 91%. That's where it stopped last time. For what I can tell, what happens in the last 9% is the vulnerability scans, and to be honest, I'm not eager to wait for this because it works. Trust me. We will let this software run and we will build up on this cluster the next time, where we will show how we can integrate Otomi with an external IDP, because as mentioned, it's enterprise software and most of them want to bring their own users, which makes it easy for you to, again, save time and apply your own policies on top of Otomi. And we will show how Otomi actually works. So we will create a few teams, we will deploy software, we will use Argo CD. We will make that URI a little bit more secure for modern browsers. That means we will switch from the dynamically computed thingy to valid domain suffix from one of our subdomains, and we will get TLS fully configured using Cert Manager and our DNS zones. So DNS01 validation of the zones. This also uses external DNS, and that's one feature we show next time. Whatever I deploy here as an application, or better as a service, as an ingress, gives me the opportunity to say, hey, my app is called my app. And now we see it automatically applies the DNS zone and uses this as a subdomain of the DNS zone. And that also works beautifully if we have a custom domain like ayedo.dev and external DNS configured. So Otomi will take care of setting up the DNS record in our zone at Azure or whatever is currently supported. I believe it's Azure, Google, and AWS. But as far as I learned, the team mentioned that they're already working of making all the external DNS plugins that are supported available in Otomi, because I, for example, use Cloudflare, and that's not working today, but I'm sure it will be in one of the next releases. So there's more providers like even Hetzner Cloud or whatever is supported by Cert Manager and external DNS. Okay, but enough of that. One last glimpse into KubeClarity. Okay, we do still not have the vulnerabilities. I'm sure it's scanning them. We will show them next time. And wrap this up by saying we have installed Otomi. I've talked about half an hour, but the main installation process took about 10 minutes. Otomi persists all of its configuration into a Git repository. And that Git repository is running inside Otomi, and is also you're able to use the Git repository, and that's how it meant to be used, to create project for your teams. So whenever I create a team, there will be a namespace created in Gitty, there will be a project created in Harbor in case I install it, and so on. And you're pretty much able or supposed to run your repositories and your code from there. And Otomi then manages all the lifecycle. You can create policies, network policies and stuff around on top of that to make sure that your teams that might work on different use cases do not interfere with each other and are not able to see things they are not allowed to see. So, wrapping up, Otomi is awesome. It took me a little while to get everything right. It works pretty much with every Kubernetes cluster on Earth. They are better integrated, or they have custom integrations with providers like Azure or Google Cloud. And they told me that has something to do with the size of the minimum size of volumes, for example, at certain providers. Most of the volumes that they build, persistent volumes, do not need full 10 gigabytes. They are perfectly fine with 1 gigabyte. But some providers have a minimum size, and that's why they build custom integrations that you can configure in the Helm chart for the bigger providers. For us, we used the custom integration. That means we are just a basic standard Kubernetes provider with ayedo Fleet, and that worked beautifully and out of the box. What I can tell on top of this, Otomi works also beautifully with IPv6. So we have here our increases that I cannot click for now, not sure why. Maybe my lens has gone rogue. Nope. Here you have increases. They are mapping to this IP address, and it's totally fine if your ingress load balancer exposes an IPv6 address. Otomi can still make that happen with actually no effort. We checked it, we tried it, works beautifully. So that's pretty much it for today. Wrapping up again. Thanks for taking the time, learning how Otomi works, taking the time for listening what it is able to do, and I hope we will see and hear each other again in the next parts of the series where we show what is Otomi actually doing for you, why you should use it, and how we can make that whole setup process or the whole instance a little bit more enterprising and integrate with big cloud providers, TLS providers, DNS providers, and stuff like that. So thanks a lot for listening and for watching, and see you next time.